You may remember that when we did Hess's law, I told you that Hess's law is one way to figure out the enthalpy change for a whole reaction. Well, we're getting ready to figure out the other major way, besides measuring it in a laboratory. So we have a new definition here. It's heat of formation, which, as we already know, is an expression, a balanced chemical equation that shows you how a given substance is created. And the rule is we have to have 1 mole of it. So if you look here, this is question 4 in your workbook. It's asking for a heat of formation expression for silver nitrate. And by the way, silver is always +1 when it's a cation, so there's going to be 1 silver for each nitrate. And I'm going to write 1 mole over here because it's always making 1 mole. By definition, that's what heat of formation is. Now on the left side, we're going to list all of the elements that are on the right side over on the left side individually the way they exist in nature. So metals generally exist just as solids. So we just write the name of the metal or the symbol of the metal followed by solid, unless it's not a solid like mercury. Then the next element to consider is nitrogen. As we know, nitrogen exists as N2. It's a diatomic molecule and it's a gas. So I'm going to write N2 gas. And then we know that oxygen exists as O2 gas. A lot of these you just have to know, but here, just with this one example, we have all metals figured out and we have our diatomic molecules. That's a huge chunk of all of the possible elements. Okay, so then once you do this, you just have to balance it. So for nitrogen, here I have N2, so I'm going to write 1/2 here. And then for oxygen, I need 3 on the right and I have 2 on the left. So what coefficient could I put in front of oxygen that would allow me to make this 3 oxygens instead of 2? Well, I could write 3/2 because 3/2 times 2 is equal to 3. So notice here that we have these fractions, which is always we think of as being a no-no. But if you recall, whenever we tell you that it's a no-no, there's always this caveat. There are rare times when you can have fractions. This is a classic example of when you can have a fraction. It's for a heat of formation expression, and the fraction is forced sometimes because of the fact that you need 1 mole in the products. The other thing to note is that these heat of formation expressions typically are not showing you the way the substance is actually made. Okay, so silver nitrate is not made in this way. This type of reaction is a formalism, and we're going to see why they're written in this way as we continue.